All right, it's 1:30, so I guess we'll go ahead and get started. Thank you all for coming. Hopefully everyone enjoyed lunch. Thanks for picking this session. So this is dipping your toes in Azure Data Lake for DBAs. I'll run quickly through the slides I'm sure you've never seen before, but please silence your cell phones and laugh about it like this lady. Be sure to check out everything PASS has to offer, because there's way more than PASS Summit. As you may or may not know, we have 24 hours of PASS and local groups and virtual groups and marathons and other things like that. So if you are enjoying your experience here and weren't aware, you can also enjoy some of this from your own home through the virtual events, and also meet up with others at SQL Saturdays and user group meetings as well. And finally, please, session evaluations. Everyone's here to learn something. Speakers are here to learn things too, and to improve our speaking. And the best way we can do that is through your feedback. So you can please take a few moments and fill out evaluations for any of the sessions you're in. Speakers and PASS itself would really appreciate that. Very briefly about me, my name is Bob Pusateri. I'm a Microsoft Certified Master, MVP, friend of Redgate. I do a whole bunch of things. Probably the best thing on this slide is my email address, best way to get a hold of me, and my Twitter handle. I will have it on the last slide as well. If you have questions or anything that I can't address during the session or afterwards, feel free to drop me a line and I will absolutely get back to you. Here's our agenda for the day, the things we're going to talk about. This is an introductory session, so it was written with the idea that the audience is familiar with SQL Server or another relational database platform, and you're curious about Azure Data Lake. So if you were coming here expecting any type of like deep technical dive into Azure Data Lake or anything like that, this may not be the session for you. Feel free to find another one if you want, but this is going to be more of an introductory session for those who maybe have heard the term Data Lake, especially with some of the other announcements Microsoft's been making this week, and are wanting to learn a little bit more about that. So we'll start with data. And data can be a whole bunch of things, right? Data can be about your customers. Maybe, I think most organizations are probably storing data about their customers at this point. It's a pretty safe bet. Maybe you have data about your business too, probably. Or maybe data is your business. Maybe you're in the business of collecting data and distributing it or selling it or whatever to other people. That's very plausible in this day and age. And this data has value, right? It's valuable to you. It's about your customers. It's about your business. It's also valuable to others, which is probably why they're doing business with you in the first place in a lot of cases. Though the fact that this data has value is also, has security implications, as was discussed during the keynote this morning. And with all these things combined, I would argue that data is, in a lot of senses, the new currency, right? Data has a lot of value. People are now actively trying to break into companies and steal data. It's worth the effort at this point. I would argue it's definitely a currency. And so where do we keep that currency? Well, if we were talking about real currency, we'd probably have, like a wallet or a purse or something like that. And that's good for storing, a relatively small amount of currency, the amount you'd keep on a person. But when you have more and more currency, this no longer works. They don't really scale very well, right? So we get more currency and more value, and now we have to upgrade to something a little more formidable, right, in terms of maybe security and size. So with that in mind of sometimes we need more, let's turn it back to SQL Server and databases. And we have SQL Server, which can do a ton of things, right? I've built my career on SQL Server. I'm guessing many of you have as well. And SQL Server is getting wonderful new capabilities all the time, as have been announced with SQL Server 2019 and all the other things that are coming out this week. But there's still some things that a relational database doesn't do very well. And while that list of things is shrinking rapidly, there's still cases where SQL Server might not be the best tool in our toolbox to accomplish our needs. And this is where I would argue that Data Lake comes along and might be able to solve some of these issues. So what is Azure Data Lake? Couple definitions you can find online. What it boils down to is an extremely scalable storage system with a lot of helpful tools bolted on. Data Lake is very powerful. It's very expandable. Some would say it's dumb storage. I would argue it's not really dumb. It's got some great tools and value built onto it, but it is a storage system. So when you think of SQL Server, you say, okay, SQL Server has a storage engine, right? And it also has a query processor and an execution engine and an optimizer and all these things on. Data Lake doesn't have that. Data Lake is storage. You need to bring everything else to Data Lake to accomplish anything. Otherwise, it is effectively a disk, right? A really, really big disk with some great tools built into it that sits in the cloud. Or can sit locally depending on how you set it up, but we're talking about Azure Data Lake today in the cloud, and it is storage. So it is designed to integrate with many different services and sources for both input and output. The idea is you can take your data and have very little or no transformation and place it in the data lake and make it accessible for people wanting to utilize that data later. Right, so you can take data from the web, data from streaming sources, files. We'll talk more about what you can and should or should not put in a data lake. And then you can analyze it with tools like Databricks or Azure SQL Data Warehouse, except on Monday we learned that Azure SQL Data Warehouse isn't a thing anymore because it's now been replaced by Azure Synapse Analytics, if you weren't aware. So I had to make some very last minute changes to these slides because Azure SQL Data Warehouse really isn't a thing anymore. Those features have been rolled into Azure Synapse. And then Power BI, you can take data in your data lake, analyze it with tools like Power BI. You can use other tools like Hive. But the idea is you can put your data in a data lake in its native format. I used to work at a place where we had data from a lot of different sources, and we had a ton of people that spent a lot of time working in integration services, taking this data from all these sources and making them fit into the box of a relational model to go into SQL Server. It was a lot of effort. We spent a ton of time doing it. Some of that data should have gone in there. Some of it probably shouldn't have, but it was the best tool we had at the time. Now we have things like Data Lake that can help with that. Pardon me. So, brief introduction. Azure Data Lake is, in other things, it's performant. It has great linear and virtually infinite scale. This scale can occur on demand. It supports a whole bunch of different access patterns because it's designed to work with all the different data processing tools out there. So it can very, very adaptable in that sense. It's got some great security features built into it. And it's also got a whole bunch of APIs, REST APIs and what have you to access that data and interact with the data lake at that level. Data lake is, like I mentioned, bring your own engine. There is no execution engine in a data lake. So you're going to be executing this data and manipulating it with something else, like Databricks or Spark, or visualizing it with Power BI, Synapse Analytics, Azure Data Lake Analytics, etc. And of course, I'm choking as I'm talking here, pardon me. But there is no compute or query processing that is part of Data Lake. You need to use something else to actually analyze and access this data. So Data Lake is, at the end of the day, it's a really great tool to have in your toolbox, which is why I'm hoping you're all here. You want to learn about maybe something extra that can help maybe help your organization in the future. And honestly, some of the work that you're already might be doing with tools like SSIS or with a different archive process, Data Lake might fit into that pretty well. So in the classic model of OLTP versus data warehousing, I would argue that generally data warehouse or data lakes are more aimed towards data warehouse type workloads. We're doing analytical type processes. We're reading a lot of data, not necessarily writing a lot of data, but we're pulling things together from multiple systems, again in multiple formats from places, as opposed to OLTP type workloads where we're more manipulating individual records as part of a transactional system. So the question is, a data lake is a concept?
Yeah, because if they know anything there, just you can put something there, just like concept for disk, concept for storage.
So the question is a data lake a concept for storage? I would argue in some ways, yes. I mean, it's a product tier tool, right? And there's a product with tools that have been built on top of it, but you could take disks in your organization and effectively build a data lake using some of the principles we're going to talk about here as well. So do you still need to install SQL Server? To have a data lake itself, you do not need SQL Server, right? This is a separate idea. You can access data lake data with SQL Server, which we'll talk about in a little bit, but you do not need to have SQL Server installed to have a data lake in your organization at all. Okay, did that?
Okay, so how to put data? Just put data there, just like storage, store the file data, store the SQL data, just like this way.
So do you store files and SQL data in there? You could store SQL data in there too, but I would not do that.
No,
That's
you said the data lake, right? You can just like store the MDF file and store the like text files, put there, just like this way. Or
could you store? Let's.
I still not just what is data lake? Because you seem like okay, no computer, no engine, just put data there. So it seems like I can put the SQL data file. I can put the
Okay.
SQL data file.
So the question is since a data lake is storage, you could put any type of file in the data lake. Is that the idea? You could put any type of file in the data lake, right? I would probably not put a SQL, MDF, or LDF file in my data lake. I think that would create a lot more problems than it would solve. And you'll see that the performance you're going to get for a SQL Server type workload would not work very well in a data lake. It's designed for a completely different type of access pattern. Also, it's in the cloud. But generally, it is a storage system, so I apologize if I didn't make that clear. We'll take one more question over here, and then I'll move on. How does data lake differ from blob storage? Okay, so do you know the difference between a good question and a great question? So a good question means I know the answer, and a great question means I have the answer on a slide that's coming up. So this is a great question. Just hang on a second, and I'll get to that because we're coming up on that soon. So what goes in a data lake? And we kind of just talked a little bit about that. In the model of structured versus unstructured data, first of all data has structure, right? But whether it's a text file or a SQL Server database file or a JPEG or a PDF, there's all structure to every file. That's the only way we can read something is we've agreed on this is the structure of this type of file. But for purposes of this presentation, we're going to consider relational data to be structured. So if you have something already in a relational database, you have enforced a structure on it relationally at that point. What we're really more interested in for a data lake is everything that's over on the right here. This is what I would consider to be the big data stuff, right? We have text files, JPEGs, PDFs, CSVs, JSONs. So the unstructured, lacking structure because it's essentially a file and not relational data or semi-structured data. This is your prime material for putting in a data lake. If you have data that is already in a relational database, I would recommend probably keeping it there. For the most part, you're not going to take your SQL Server tomorrow and empty it out and throw it in a data lake. That won't work out very well, I promise you it won't. Hang on. There may be use cases where, as part of like a data promotion or disposal policy, there's no sense in keeping that data sitting in a SQL Server for 10 or 20 years if nobody's going to look at it, or you're maybe going to look at it once or twice a year. That may be a good candidate for exporting and putting somewhere like a data lake. But generally, if you have relational data that's already in a database, I would keep it there. Big data has terms that have been agreed on called the 4 Vs. And generally, if you meet these, you are considered big data. So you have volume, your data is really growing very well. You have variety, you have different types of data that may not necessarily fit into a relational database. Again, images are a great example. You probably don't want to put images in your relational database. I had a radiology team come to me once and say, oh, we're going to put MRI data in the database. And I'm like, no, you're not. No. So maybe you'd have some structured data in your relational database that is metadata on unstructured data sitting somewhere else, like in a data lake. This data has velocity, so it needs to be processed. Is it from a streaming source, perhaps? Is the data trustworthy? What's the veracity of the data? What is the lineage of the data? Where did it come from? I really like genealogy. I keep my family's history. I have all kinds of information I've collected over the years on my ancestors. And one of the things, if you do genealogy, is you'll find a lot of information on individuals that don't necessarily agree. I have some members of my family, I don't know when they were born. I have 3 or 4 different answers on when that occurred. I don't know what's right. So what you typically do in genealogy is you keep all of them and just make note of the source. oh, the family Bible says this, but the government records say that or whatever, and you kind of try to build a picture that way. Data lineage in any situation is a lot like that. So with one of the ideas with big data, when you get into what's called a raw zone, which we'll talk about in a little bit, is you have the raw data and you can trace back from, I arrived at this result because I started with this value. That is a great case for a data lake. And finally, the fifth V, value, right? Are we creating value from these four above things? If we're not creating any value from this data, then why are we storing it? So let's talk about data lake storage, which goes back to that question I got from over here real quick. Who here has worked with Azure Blob storage? Okay, decent number of people, right? So Azure Blob storage, I would argue it's one of the gateway drugs to Azure. It's really easy to set up, pretty cheap. You pay for what you use, storage-wise, and storage doesn't generally cost a whole lot. So this is just the Azure Blob storage service. We're not talking about the data lake service yet, but it's known as WASB, or Windows Azure Storage Blobs. This is optimized for unstructured data like videos, files, and images, and whatnot. It is a flat structure. It is really easy to store lots and lots of things in a big old list, and that's exactly what this is. Now, if you've used Windows Blob storage, you may say, but wait, I can create folders in that, but the folders you create are actually fake. All they're doing is behind the scenes, they're appending a slash in a folder name to the file name, which is why if you delete all the files in a folder, you will notice that the folder itself disappears too, because the folder was never really there. It's just inferring the folder's existence based on the file names in it. So it's a flat structure. There's no directory tree in Windows Blob storage. It is the lowest cost storage option in Azure. It's cheaper than Azure Data Lake storage, which we'll talk about in a minute. And there's a whole bunch of different tiers you can have of blob storage depending on what you want. So you can say, I want more redundancy, I want more performance, this is what I want my account to have, this is what this container should have, and it will adjust the cost accordingly. So you have redundancy options in blob storage. You can create a locally redundant copy, which is essentially just multiple copies of the data in a single data center. So, if a part of the data center goes down, you're fine, but if a tornado takes out the entire building, you've got a problem. But that's the cheapest option. There's zone redundant storage, which will store multiple copies on different availability zones within a single region. So these zones have separate power, cooling, and network. So part of the region can go down and you'll still have your data. There's geo-redundant storage, which will automatically replicate your data between regions, and you get a single endpoint. This is kind of nice. So if you have, your images are here at this endpoint, if for some reason the entire Azure region were to fail, your endpoint would get redirected to another region that has a separate copy. And then there's read access geo-redundant storage, where you can write to one region and read from another through a second endpoint if you want. So you have these options here of what level of redundancy do you want in your blob storage account. You also have tiers for performance in a blob storage account. So there's the hot tier. This is data that's accessed the most frequently. There's a cool tier, which is for less frequently accessed data. And then an archive tier, which is for data you're probably never going to look at but need to keep safe. And the prices adjust accordingly. You'll pay the most to store hot data, but you'll pay the least to access that data. Whereas with cool tier, you'll pay less to store that data, but you'll pay a little more every time you need to touch it. Archive is really cheap, but it's also really slow to retrieve, generally in the order of hours, though there's now expedited rehydration and archive storage. So I think you can get it quicker than that if you're willing to pay more. And there's minimums on some of them, but you get tiers in terms of redundancy and performance, and this will affect your price. But you can kind of choose your own adventure with Azure Blob Storage, which is really nice. So that's Azure Blob Storage. Now we'll talk about actual Azure Data Lake, and there's two versions of Azure Data Lake. There's Generation 1 and 2. Azure Data Lake Generation 1 is a product in Azure. So you would go to Azure, you'd say, hi, I want to provision something new. I want to create a new Azure Data Lake Generation 1. And that is an actual product in the list. I'll show you in a screenshot in a moment. It's known as ADLS, or Azure Data Lake Storage. It was designed to be interoperable, so to work with all the major MPP platforms. It's got security built in, so you have access control lists and Azure Active Directory integration for determining who can access what. It was optimized, it was built for analytics type workloads. It does not have a file size limit. Azure Blob Storage does have a file size limit. It's like 4.7 terabytes per file, but there is a limit, whereas there is no limit in Azure Data Lake. And it has a real hierarchical folder structure, no fake virtual folders like you'll find in Azure Blob Storage. So we had Azure Blob Storage and we had Azure Data Lake Generation 1. Then more recently, about a year and a half ago, they came out with Azure Data Lake Generation 2. And this is known as ABFS, or Azure Blob File System. So this is implementing Azure Data Lake on top of a Blob storage account. So it is no longer a separate product. You'll kind of see in the screenshot on the right there. So we have Data Lake Storage Gen 1, that is a product. And then at the bottom, there's ADLS Gen 2, that is a type of storage account. So what you do to create an Azure Data Lake Generation 2 is say, I want an Azure Blob storage account, and I want to put the Azure Data Lake Generation 2 file system on it. That is how you create Azure Data Lake Generation 2. It has more support for different authentication schemes and MPP platforms than version 1. It's got the same folder structure. It's now got atomic file operations. It's got all the tiering options of the Blob storage that we talked about because it is a Blob storage account. And most importantly, it is cheaper than Azure Data Lake Generation 1 because it's a Blob storage account, right? Microsoft kind of took, and I show it on this slide here, they took the factors of Azure Blob Storage and Data Lake Generation 1 and kind of combined the best of both worlds, Miley Cyrus style, to give you Azure Data Lake Storage Generation 2 at the bottom. So you get the features of the file system storage, which is awesome, should make everybody happy. But you also get the cost and the scaling availability of the Blob storage in an Azure Data Lake Storage Generation 2 account. So that is kind of how the storage account parts of it work. Are there any questions about that? Why would you pick Gen 1 then? If you're doing anything net new at this point, I would not pick Gen 1. I would say anything new you're doing should be on Gen 2 at this point. There are certain scenarios that Generation 2 does not support yet, I will tell you that. But those are very quickly being rectified. Say what? So there's some compatibility with Generation 2 still, but they are rapidly reducing that. And I haven't even read through everything they announced at Ignite this week, so those might be completely gone now. But Generation 1 still exists. But if you're doing something new and saying, hey, I want to spin up a data lake tomorrow, I would start with Gen 2 at this point. Any other questions about that? Yes?
So you migrate to
The question is, can you migrate from Gen 1 to Gen 2? There is no prescribed migration path that I know about. You would be basically creating a Generation 2 account and then copying the data from one to the other. That is the migration path I am aware of, at least. So there's no tool like upgrade my Gen 1 to a Gen 2. No, it doesn't work that way. Anything else? All right, let's move on. So we've talked about what a data lake is and kind of how it works on the storage side. A little more about what we're putting in it. We have a lot of file formats at our disposal, right? And that's primarily what this is designed for, is for different types of files. So we have, text files, human readable text files, right? So text and CSV, these are great. These are well supported. Anyone can read them, including you. You can open them up in a text editor and see what's in them. We also have JSON, which is good, a little more efficient than XML, supports nesting. Files can get a little large with JSON sometimes. And then we have the more interesting formats, which are not necessarily human readable. So first one I'll talk about here briefly is Avro. Avro is a two-part file format. So there's a JSON part of the file that stores a schema, and that you could, of course, read. But then there's the binary portion where the actual data is. So the data is compressed in this binary portion. Because we have this schema data, we can have schema evolution. So maybe the schema has changed over time. That can be reflected in the file. and actually passed along, so we wouldn't have to change everything, which is kind of nice. But you do need a custom utility to read Avro files, which are not hard to come by. There's even a plugin for Visual Studio Code that can read Avro. So not really hard. But the two really big popular ones these days, and I'm guessing some of you have heard of these are called Parquet and Orc. These are column formats. So kind of like the columnar compression we have in SQL Server, this kind of does the same thing with files. And Parquet was kind of developed by Cloudera and Twitter, and Orc came from Hortonworks and Facebook. These support compression. These support predicate pushdown, so we can have filtering availability without needing to read the entire file, which is great. That can really help our performance. Because it is a compressed and a columnar format, though, it's a little slower to write to these, right? We got to write it in and compress it and do more than just simply write bytes to a file like we would do with a text file. And at this point, I have to point out that these are column formats, and they're great, but column store still doesn't solve everything, right? How many people have had the performance problem with the database, and they're like, but we put it in the column store table, that should fix everything, right? It should just be faster because it's a column store. I used to get that a lot as a consultant. But no, column store solves a lot of problems and makes things great, and we'll actually see that in a demo a little later on, but still doesn't solve everything. But these column formats, they're generally better for analytical workloads. Of course, test your workload. But if you need to query over data multiple times instead of just once, or if you need the column elimination features or predicate pushdown performance advantages that you get from a column format, they're probably worth the effort. Now, it can take some time to put your data in a column format. In fact, I have that in my demo, and it takes so long, I'm not going to do it in front of you because it takes like 10 minutes to do that part of it. But once you do it, you get ridiculous performance benefits, and we'll see that. Putting things in a column format can also reduce or eliminate encoding issues. How many people have ever read a text file and had a problem because it's UTF-8 and they didn't include a byte order mark in the file or something like that, right? This can be a headache, and then you got to go do the wizard again, and it's all annoying. With formats like these, those problems are taken care of for you. So that's kind of nice. Now, where are we putting all these files? Because we have a folder structure, a real folder structure in Azure Data Lake now. And the term for folders are zones, right? So zones are folders, and really with a data lake, organization is what matters. If you're gonna have all this data in a data lake, and the idea is we're gonna provide it, to our users as a self-service, or let the data science team go wild with it or whatnot. There's got to be some organization to it, just like with anything else in life, right? So there's some common zone names we'll go through, and some organizations sometimes have other zone names, and some have subzones and things like that too. Some people will use zones to implement their dev, test, and prod environments. And you can restrict access to zones through the security features that are available to you. But let's talk about some of these zones. So probably the most basic of the zones is the raw zone. This is where you keep your data from the source system in its original state. So you would bring it in from wherever it's coming, and ideally you're never changing anything from it at this point. So you have a copy of the data literally in its raw state. And you would divide this up in the zone by the source system in the schema. So I have some data. I'll show you how it looks in a raw zone. But we want this data to be immutable. We want it not to change. We would append the data, we'd add to it, but we would never change something once it's in there. Probably the biggest change you'll see in a lot of raw zones is just simply partitioning out the data by date. From the raw zone, we would take and process this data and put it into a different zone. Probably one of the first ones would be curated, and this is where you store the data in a more transformed state. This is where, like your data warehouse or your data mart, those would generally be considered curated zones. This is where you would expose data to the end users. Generally, you wouldn't expose them to raw data unless they had a specific need for it. This is where data governance is going on in this zone. This is trusted data at this point. And really, kind of make your own adventure as far as how your organization wants to use a curated zone. I've seen them done as far as like, this is a curated data science sandbox. These are the data marts. This is data going outbound for integration later in a different process. But you have a bunch of different things you can do with a curated zone. But the idea is it's not the raw data. It has been transformed in some fashion to make it available. Or if it hasn't been transformed, it's been copied and presented here so that there's always a copy in the raw zone that is not getting changed in any way. There's also can be temp zones. If your incoming data is mutable, if it has to change, if it's coming from a source where maybe it has to change, this is where you could kind of stage changes before writing them back to a raw zone or doing batching, something along those lines. Depending on what you have coming in, it might be more efficient to do this in a temp zone than in the raw zone. You would compare data. You could calculate deltas here and put those deltas somewhere else. You can archive files here or vacuum or delete them per your needs. But that's pretty much what you use a temp zone for. Archive zone is for data that's no longer in an analytical window, so maybe the data that you need to hang on to but aren't going to touch anymore. You need to hold on to it for compliance issues or whatnot. And you can restrict access to any zone or structure via access control lists and what have you. So you could have this data here sitting still technically in the data lake in a different zone that is highly restricted as to who can touch it. And usually the archive zone is the last place this data goes before being removed from the data lake. So if you have somewhere that it goes after that, maybe it does get deleted, maybe it goes onto tape in somebody's basement or something like that. And because Azure Data Lake Generation 2 supports tiering within the containers, you can actually have different tiers. So you could have the archive zone be an archive tier of Azure Blob storage, which is really, really cheap to store at that point, and it's not changing, and you're holding on to it, and it's all good, but you're not paying nearly as much as the active data that you're actively and frequently reading. Generally, about now, I get a question about moving data between zones to the point where I actually added a slide for it. So moving data between zones, typically this isn't something you actually do. There are tools that can do it. So Azure Data Factory is great for this. You can orchestrate stuff to happen in Azure Data Factory and move data between zones. You can do it with your MPP engine itself, like Databricks or with Uzi. You could use AZ copy, which is the Azure copy utility, and move between the zones. But usually you're not moving data between zones. You are transforming it and creating something new. You're not saying, I'm going to take this data out of one zone and write it into another. Like move style, I'm going to read it in and perform a transformation and output the result to a different zone. That is the typical usage pattern for data zones. Any questions on this part before we get into processing? Okay. So data processing, we have a whole bunch of different engines at our disposal. Because like I said, Azure Data Lake is designed to work with a lot of different things. Some of the more common ones you might see here, so we have Azure Databricks. We have the one in the middle on the top, that is Azure Data Lake Analytics. That's kind of an older one that was designed for Generation 1. We'll talk about that briefly. We have Hive, which comes back from the original Hadoop days. We have Azure SQL Data Warehouse, which is now, as I said, the Azure Synapse Analytics. And that's not even the right logo for Azure Synapse Analytics. I was trying to find the logo for Synapse Analytics, and that's what they had on their website. But apparently, the actual Synapse Analytics logo is that little S thing in the hexagon in the middle. So I was wrong with that. Engines like Spark can also do this. So you have a whole bunch of engines at your disposal that can interact with Azure Data Lake. And this isn't even considering other things like visualization tools. Like I said, Power BI and a whole bunch of other stuff can all plug in and work at it too. Microsoft has a great graphic here, which is now outdated. Just kind of how Data Lake fits into a pipeline. You'd have data coming in, going through something like Azure Data Factory or maybe a Cosmos DB, something for ingestion, and then being stored in Azure Data Lake, where you then perform, modeling, whatnot. You could use a tool like Databricks, transform that data, write it into something like Azure Data Warehouse, except not anymore, and then go and visualize it through Power BI. So Data Lake is kind of present for multiple steps in the pipeline there. It's kind of like the shared enterprise storage that all these other tools can talk to, and data can come into through ingestion methods or just flat out through copying files as well. But Azure Databricks, which is the first, this is, like I said, this is the newer cloud-based analytics platform. It's based on Spark. I have a demo later. I'll actually show you some things we did in Azure Databricks, and I got a notebook that's part of a download package. You can try and mess with it yourself if you like. This is if you're doing any net new stuff at this point, I would argue that Databricks is probably what you'd want to go with. That's just my personal opinion. Of course, then we also have Azure Synapse Analytics, which is the brand spanking new one that I really don't know a whole lot about. But the idea is that you are bringing together your data from a data lake and your relational data from SQL Server and seamlessly being able to query across them in the cloud, which sounds pretty awesome. I just need to work with it a little more. This is, like I said, the features of Azure SQL Data Warehouse have been rolled into Azure Synapse Analytics. And it was, before that, it was SQL Parallel Data Warehouse, if anyone remembers that one. And I know there's some great sessions here on Azure Synapse Analytics, and probably still some left for the rest of today and tomorrow. So if you want to learn more about that, please go to a session, because they'll be able to talk about it. I won't. One of the older tools that came out with Azure Data Lake Generation 1 was called Azure Data Lake Analytics, or ADLA, it's known as in a lot of places. ADLA is kind of, it's still there, but once again, Microsoft is saying if you are doing net new development, don't use Generation 1 and don't use Azure Data Lake Analytics. There's better things going on at this point. ADLA has a language called U-SQL, which is its native query language. It's kind of a combination of both T-SQL and C#. So if you can read both, you'll be right at home. And you can execute U-SQL either in the cloud or locally if your data is local. I have a link to a thing you can do in Visual Studio where you can play with it locally if you don't want to provision anything in Azure. And this is what U-SQL looks like. So we have this concept of what are called row sets, which we're defining in the first row there. We're defining a row set as a query, as an extract of some columns with specific types from a tab separated variable file from a TSV file, right? So we're reading from the file, we're using an extractor with a function that looks like C#, and then we're projecting some column names and data types onto it, and something that looks like T-SQL, creating this row set. And then in the bottom part, we're actually outputting that row set to another file. So we're taking a big file, we're reading a couple columns from it, and outputting it to another file. This is something very simple in U-SQL, and by looking at this, you can probably see the elements of C# and T-SQL in it. Another more legacy product at this point, I probably wouldn't use it as my first choice, is Hive. Hive was originally designed to query on top of Hadoop in a language that is also similar to SQL. Their language was called HQL or HiveQL, and theirs was extremely similar to SQL. That's a Hive query right there. The idea being that you could take DBAs who know how to write SQL, and they will be able to figure out what's going on in Hive rather quickly. So these are just some of the tools you could use to access and manipulate data in Data Lake. Again, if I was doing something new, I would probably start with Databricks or Synapse these days, but there's a variety of things that it's all compatible with. So let's talk about some design considerations. We've been talking about what to do and how to do it, but not really some of the best practices and some of the screw-ups I've seen. Since Data Lake is a file system and a collection of files, file naming is really important. It's always a great idea to have both a source and perhaps a date in your file name and to be very consistent with it. Because what you're doing with a lot of these MPP engines is you're pointing them at a file or even more likely a directory or a directory tree and saying, hey, go process everything in this tree. You want all the names to be consistent and the contents and the types of what's in the files to be consistent as well, otherwise you're going to run into issues. So for example, if I had data on parking tickets, which I do happen to have, and we'll see that in the demo, maybe I have a daily file or an hourly file of all the parking tickets that are written. I might name my file something like this, parking tickets with a date and then a time on it, and then I know what exactly is contained in that file. Partitioning matters in Data Lake. It's very different from what we talk about in SQL Server, but the idea is to try to make the data so-called splittable. If you have a relational database and you create like one table per file, you might run into problems as the size increases. Not very splittable across multiple nodes. And a lot of these MPP engines, you're trying to take a workload and split it across a whole bunch of machines to do it. You want to try to help it as much as possible. So if you have multiple files, it can easily split that work. Usually you'd split up by date or something like that. but you also don't want thousands of files in a single directory. That can be a problem too. So maybe split up by year and month, as in the example there. Try to avoid creating empty files and folders. That can mess things up, depending on what engine you're using. And do not mix data types within a folder hierarchy. If I have a folder full of parking tickets and then I have some files that contain other data like building permits or something else that's not related to parking tickets in there, and I point my MPP engine at this directory and say, hey, go process everything in this directory, it's going to start looking at the other files and become confused rather quickly. So separate your data out by its type. So just to give a more visual example of partitioning, if we were in a raw zone and we had parking ticket data, again, we'd have a folder for the year and then the month, and then the actual file itself would be at a level below that, and you'd have this whole tree structure. And then you could go to your MPP engine and say, hey, process everything in parking tickets, or maybe everything in parking tickets 2017. Some file formats are known as being splittable themselves. So the MPP engine can actually split a single file into multiple segments and divide that amongst worker nodes for benefit. Some MPP engines cannot split compressed files. You have to read your documentation and see. Some of them can handle compressed files. You can gzip these files and it'll work just fine. Others won't. So it really varies. And if the format is unsplittable, that's where you need to manually manage your partitions, as I kind of just showed you. But some of them you can actually compress everything and point it at it, and it'll do just fine. If you have poor partition management, you can end up with poor performance, kind of along the lines of a SQL Server query with out-of-date statistics, right? You end up with not dividing your workload against your worker threads correctly, and then you end up with CX packet waits, and things take longer than they need to be. So try to help your MPP engine wherever you can in that sense. As I mentioned, compression can make some formats exploitable. Some column formats have internal compression already, like Parquet and Orc that we're gonna see. Sometimes you can even layer these with gzip across files if you really want to. But again, read your documentation, and your compression may not improve your performance in all cases. So this is where you test your workload. That's really the only way to tell if it's going to work for you. As with anything else, compression is always going to be a trade-off. There's no free lunch in computing, so you'll save space in terms of storage, which will save you some money, and you'll save memory and I/O and network, but this all comes at the cost of CPU, right? Now it takes more work to compress and decompress this data as we're processing it. So you might need beefier CPUs to make up for this, which may cost you more money, which may cost more than the storage space you save. So again, this is why we test. As far as general architecture patterns, there's two very general families for MPP processing with a data lake. There's the batch pattern. So we have our data coming in from a data source, going into something like Blob storage or data lake or Cosmos or what have you, getting processed by U-SQL, Hive, Pig, Spark, and then either going into an analytical data store or maybe going straight out to analytics or reporting. And this is all being orchestrated with something like Azure Data Factory, HD Insight, what have you. And then you have data streaming in over time, it's getting batched and it's getting processed, right? This is probably the easiest to conceptualize coming from a SQL Server world, because a lot of things we do tend to be in batches, right? That's kind of how T-SQL is written. This is great, this works, these will continue working. I see no problem not to do batch, but some patterns work better for streaming. Some data formats and sources where the data is constantly streaming out of them, you could actually process them as a stream as well. This gets a little simpler in some senses because you don't need orchestration anymore. It's just constantly being streamed in and processed. But now we have to worry about how we're ingesting that data and what we're processing the stream with. And some of the stream processors, these so-called stream processors, aren't really processing a stream. They're doing micro batching, so they're creating batches really, really fast and processing them to the point where it appears like it's a stream, but not really. Spark structured streaming is one that is actually micro batching, whereas something like Storm is true stream processing. You can get the same result at the end, often with less work once you get it working, and you don't have the overhead of the orchestration going on because there's no orchestration necessary at this point.
Question.
Yes?
I'm not sure if you're going to go into this later on, but when would you pick stream versus batch? And does it make a difference if it's coming into the MPP or out?
Question is, when would you pick stream versus batch, and does it make a difference when it's coming into the MPP or out of the MPP? I wasn't really going to touch on that here. That's okay. Generally, I would argue it's where is your data coming from? Is it a streaming source? Are you looking at tweets coming in? That's a streaming source. If you're getting batches of files from a client or from some other office in your company, every hour, I would argue that's a batch source, not a streaming source. But that's very general. Any other questions? Okay. So let's talk about some anti-patterns. We talked about some patterns with all our zones and everything else. How about the anti-patterns? Probably the first one is the data swamp, right? We want a lake, we don't want a swamp. Swamps have crocodiles in them and whatnot. Poor organization is probably the biggest cause of a data swamp. So if you have multiple file types within a folder, as I talked about, that can make things hard for both end users and for processing engines. If you don't have standards with your naming or data governance or a data catalog to actually find and direct your users in a self-service matter, anything that makes self-service difficult, you could find yourself with a data swamp, and you really don't want to do that. Small files can be an anti-pattern. As I mentioned earlier, if you have lots and lots of really small files, this can actually add processing overhead and create more work for your MPP engine. Most of the compute engines actually in their documentation will mention an optimal file size or an optimal file size range. So again, this is where I like to say, read the instructions. You'll probably learn a whole bunch of things you didn't know were things. And that could really help you out in that sense. Some of the challenges with data lakes. Data lakes are a great place to put a whole bunch of data from across an organization and have it in one place and have it available. I'll get to your question in just a second. But the data lake itself doesn't provide an integrated view across the organization, right? We need other tools to do that. If you don't have a good governance process in place, it can be hard to guarantee the quality of data in a data lake. Usually by the time an organization has created their data warehouse, they have governance in place. People know they can trust the data in the data warehouse, whereas there may be trust issues initially with a data lake, like is this really being vetted as much as it was when it was processed in the data warehouse? Valid questions, but these are things that need to be addressed. You don't want to have a whole bunch of stale, unused data in your data lake, because then you're collecting data for no reason at that point. Goes back to the V of value. Are we providing value with the data we have? If we don't have metadata, it can be hard to determine what this data is and what it means, and is this the proper source for it or not? Again, governance is important. And as I kind of said in one of the early slides, data lakes are not the best thing for all types of data, and that's especially if you already have data that is relational, may not be the best place to put it in a data lake. There was a question over here. No?
Yeah.
Yeah.
Just a quick question on the last slide. What's the minimum size of a small file?
What's the minimum size of a small file? It's not a direct question. What's a small database, right?
Well, let's say recommend not too many small files.
Not too many. That depends on your vendor. Some vendors will say files should be no less than 64 megabytes. Some will say they should be no less than larger than that. Some will say they don't care. So it all depends. It's in the documentation a lot of times. So
Well, but yeah, last slide.
that's okay. Question?
Yeah, does encryption just jam this whole works up?
Does encryption jam this whole works up, or can you use it? That's a great question. Depends on your MPP engine. So I would argue encryption is important. Encryption can affect compressibility of data, but if you do it in the proper order, it does not, right? If we compress the data before we encrypt it, that's not a problem. If we encrypt the data first, we're not going to be able to compress it very much. It's too randomized at that point. So kind of the same issue we ran into back when SQL Server introduced transparent data encryption and also compression, right? If you tried to take a compressed backup of a TDE encrypted database, your compression did nothing for you because it was out of order. Any other question here?
Yeah, so is there a read timestamp, or how do you determine unused data?
How do you determine if the data is unused or not? The data lake itself does not provide a last read timestamp, so that would be something you'd need to implement in that point. Any other questions?
Yeah, but what about like a date created?
There's date created in there, but not. It looks, we'll take a look at it in a second here when I get to the demo point. It has information just like any other file system would, but there's no last read thing. Yeah, so. All right, more questions. Wow, we got a lot of questions here.
Is there any kind of logging that you could set up? In other words, if you wanted to track, like read these files for the last 2 days?
Is there logging that you could set up? I believe there is, but I have not tried it, so I cannot answer that with authority. I'm sorry, we're kind of off the trail at this point. Anything else? All right, let's keep moving here. We're doing good on time. Okay. I think one of the biggest common misconceptions about a data lake is that they're just for IoT data and data that's streaming in. No, they're for way more than that, I promise. You know, you can get great value from things like images and text files that are not streaming in that were archived from other portions. And data lakes can integrate with other relational databases too, right? This is especially recently. So Polybase can read from data lake. SQL Server Big Data Clusters, right? That just came out in 2019. That can absolutely read from data lake. So can Azure Synapse Analytics, which was just announced. So there are now great and seamless ways to query across both relational data sitting in SQL Server and files you have sitting in your data lake. You can define this and issue a SQL query and query against both, which is awesome because for a long time you couldn't do that. Can talk briefly about security because people like security here. Data Lake Generation 1 had authentication only through Azure Active Directory. So you had to have an AAD account set up for users and whatnot to access that. You could have roles that handled account management. There's POS access control lists for data access. So this is your standard Unix style, your read, write, execute type of permission. You could enable those on folders or files, but there was no inheritance, so you had to apply them individually. You could also create groups and assign users to groups and grant through a group instead of an individual object, which is nice. It looked kind of like this in the Azure portal. So you could assign, a role to a user, give them a bunch of role options available to you. Individual files, you could assign read, write, or execute to individual users or groups. So that's how it worked in Generation 1. In Generation 2, they actually, in Generation 1, yes, and there's firewall, as there is with pretty much everything in Azure, so you can define a list of only these addresses or address ranges can access the data lake, so it's not just sitting there and anyone can see it. And encryption is available. Data is encrypted before it's written on disk, and they use TLS 1.2 for the data while it's in motion. That was all Gen 1. Gen 2 builds on this. They have row-based access control in individual container resources now. And there's also, you don't need to use just Azure Active Directory anymore. There's shared keys and shared access signatures. So you can have keys for granting super user access. You can also create SAS tokens, which include individual permissions and grant those to users. And they added the concept of inheritance. You have that now. So you can have, but it's limited. So you can inherit permissions from a parent object if the parent object has default permissions defined on it. If not, there is no inheritance. But if you set a default permission, it would be applied. But if the default permission changes, it will not cascade down to any child object. So it's kind of like if this object was created and the parent had defaults, it'll get the defaults. But if those defaults change later on, it's not gonna cascade like a Windows permission would. And the interface was also improved for read, write, and execute in Data Lake Generation 2. So you can assign your rights to users or groups or roles or what have you from a screen that looks kind of like this. This is something to play around with. So DBA topics, because this is an introduction to Data Lake for DBAs. So let's ask some of those DBA questions we might have in our head. So what about backups, right? We have all this data, huge amounts of data, terabytes, petabytes of data in Data Lake. How do we back that up? Not the greatest story for it at the moment. You could copy to another Blob storage account with something like AZ copy, though if you have tons and tons and tons of data in your data lake, that might take a really, really long time. You can manage your redundancy, right? We talked about all the redundancy levels you can have, and that's great. That'll provide you great safety, but that's not going to prevent you from the logical corruption of, oops, I didn't mean to delete that, right? So backups are important. Microsoft has mentioned in the forums that I've been on that they are working on backups. It's in the pipeline somewhere, but there is no backup a data lake tool specifically at this point. Another question DBAs might want to ask is indexes. Azure Data Lake itself provides no indexes. Again, it is not an execution engine. This is where like your MPP tool itself or your file format would provide the indexes. This is just the storage part of it. U-SQL, the language, actually does have a create index statement, but literally all it's doing is reordering the data in the file. So it's effectively setting the clustered index of the file just by the order of data in the file. But that's it. Some of the file formats we talked about, like the Orc and the Parquet, the column formats, they support indexing. But usually that's what your data warehouse platform is for. That's not what the data lake itself is for. What kind of development environment would you use? How do you develop for Azure Data Lake? Well, you don't really develop for Azure Data Lake. You develop for a tool that's using Data Lake. So your development environment varies with whatever you're using. You know, you could define things in the Azure portal. You know, if you're using Databricks, you would use a Databricks notebook. If you're using Power BI, you'd probably be doing this in Power BI desktop. So there's no Data Lake developer environment. There's no SSMS or Azure Data Studio for Azure Data Lake. How could my organization get started with Data Lake? If we want to, try something out, probably some of the easier ways are to take like archived or unused data and offload it from a relational database into a data lake. Or you could use it as a staging area for data warehouse loading, or you could use it for ingestion. Maybe if you had a net new project, you could have that ingest the data actually through the data lake. One of the topics I know probably some people here are wondering about, what does this all cost? We just talked about a whole bunch of stuff here. What do they charge? So for Azure Data Lake Generation 1, you are paying for storage and operations and data transfers. So this is based on the US central region, so like Chicago area, Azure data centers, but they're more or less the same across the US. So you pay 3.9 cents per gigabyte per month, and then you'd pay for operations for reads and writes in groups of 10,000, and then there's a transfer charge. This is ADL Generation 1. This is actually kind of expensive, because remember we said ADL Gen 2 is based on a blob storage account, and things are cheaper. So in a blob storage account with ADL Gen 2, you're paying a different set of prices. You're also paying different prices based on the tiers, which is why there are slashes there for hot, cold, and archive tier. But you're paying, again, for storage, operations, and outbound data transfers. This is about 30% cheaper overall. But you'll notice how as we go from hot to cold to archive, the storage price goes down, but the archive or the operation price goes up, right? So it's 0.02 cents per gigabyte per month to store data in the archive tier, but it's $6.50 per 10,000 reads on that data. Like you're paying way more to read it, because the idea is if you're putting it in an archive tier, you're not reading it very often. So this is just general pricing information. As always, check the Azure website if you want to see what the current prices are, because it may have changed already since I changed this slide earlier today. If you would like to play with U-SQL for free, you can do that without provisioning anything in Azure. You can actually run U-SQL queries locally on your machine for free in Visual Studio. Microsoft has a whole tutorial on their website. You can do that if you want to try that. If you want to try anything else, you're going to need to provision some stuff in Azure to do it, which I would recommend trying anyway. And if there aren't any further questions, I actually have a brief demo I can show on that. Yes? Could you use big data clusters as a possible solution for Data Lake? Absolutely. So if you have a big data cluster defined, Data Lake is one of the things it can read from. So you could query the Data Lake, through SQL, through the big data cluster. You could join it to additional relational data you have elsewhere. But yes, that is one of the things you can connect to from a big data cluster.
I don't mean just connecting, I mean like using its HDFS file system.
Using its HDFS file system as the Data Lake. I believe you can, but I am not a big data clusters aficionado. So, any other questions? Yes.
So I'm probably just missing something, or I'm very undercapitated. What's the main selling point of Azure Data Lake versus just a massive file server?
What's the main selling point of Azure Data Lake versus a massive file server? I would argue this is your massive file server in the cloud that you don't have to maintain and will grow with infinite growth and has a whole bunch of other tools added on for extra convenience. the APIs and whatnot, yes. So, any other questions on that? If not, we'll move real quick to a demo. And all these demo scripts are available for download. I'll show you in a second here. So what I have set up is I have a data lake defined, Azure Data Lake Generation 2. It is sitting here in one of my Azure accounts. I'll drag it across. So this is Azure Storage Explorer, which is one of the ways you can browse a data lake or any other storage account. So yes, these are my storage accounts here. I have a raw zone, and I have parking tickets. And what I have here is I have every parking ticket written by the city of Chicago from 2003 to 2016, right? So if we dive down into this a little more, you'll see we have a folder for the name, for the year and the month, and then we have the files, which are all named like this. These are all just CSV files, so there's a couple thousand of these files here. We're going to query across, and to query across them, I have a Azure Databricks notebook set up to query across them. So you can download this notebook, you can run it yourself. Don't connect to my data lake. It won't be there by the time you try to connect to it anyway. So what we do here in this first step is we're actually defining our connection. What are we connecting to? How are we authenticating against the data lake? Then we're actually, and I'm not going to do this part here, but we're building out Parquet files. So we have the CSV files with the raw data. I'm taking and building a compressed, column store compressed Parquet file to do that so I can query it a little faster and show you the performance difference. So here I have counting all the tickets across all these files. And this step I ran earlier because it takes so long, but this is essentially reading through all the CSV files and counting all the records. There's no easy way to do this because there's no index, so you literally have to just read through the file and count the records. There are 36.7 million records. Hopefully that's big enough. And if I zoom in here, this took about 2 minutes to run and build that, or to just count the files, right? Not fast. There's no indexes. There's nothing helping you. So I'm not going to sit here and make you watch this for 2 minutes, but that's what that's doing. If I were to direct it instead to use the Parquet files to do this here, we're going to go ahead and run this query. This is doing the exact same work in the cluster, and this is a rather small size cluster I provisioned. But it's going to go ahead and read the Parquet files, which are again compressed and indexed, and go ahead and count the number of tickets in all these files. And we're probably going to spend more time restarting the cluster, which shouldn't have shut down, but it might take a minute to get an execution context to actually go ahead and do it. There, it's submitted the command to the cluster. It's going to read real quick. Okay, so that took 13 seconds to arrive at the same result. So clearly having the index and the Parquet files makes a big difference when we're querying this data, right? This is something we'd expect if I were to do the same thing in SQL Server with an unindexed heap and then an index table, you'd see, equally interesting results. Just to show you what some of these records look like, if you want to see, here's just 20 random records from the table. Again, these are legit parking tickets written in Chicago. So we have a ticket number, we have a real license plate, we have when and where it occurred, where they were, what they were doing, was there a fine involved, did they pay it, how is it adjudicated, et cetera. We can do some aggregations, which might be a little more interesting. So let's see what we have via car make. Count the number of tickets per make of car. Did more people who drive Fords or Chevys get tickets? And this is querying the Parquet compressed data and index data. All right, so that's pretty quick. Chevy is the winner or the loser as far as number of tickets written. Then we have Ford and Toyota and Honda. The city's data source only has 4 characters for the make of the car, but it aggregated that all in 13 seconds, right? About as long as it took to count them all. Pretty darn quick for the volume of data we just accessed here. How about the top offenders? Which license plates had the most tickets issued to them? So we'll do this real quick. And while this is running, does anyone here have a license plate that might be in this data set? Because if you do, I will happily look you up. I realize we're not really from Chicago. But if you have a parking ticket in Chicago, we can try to find you if you want to volunteer. If not, I got some demo data we'll pull up real quick. So top offender is null. Apparently the city's data doesn't have that great quality if they have null license plates in there. I'm guessing revenue is someone for the revenue department, maybe.
For the Chicago,
It's,
when they write a fake ticket,
they write it to revenue?
the revenue agency, but there's actually a license plate with that number, and he got a bunch of those tickets.
Okay, okay. So,
Yeah.
all right, so these are the top ones. You know, some person got 4,600 tickets apparently. And then we could also, you know, just like any other database, we can issue a SQL type query and query an individual record. So if there's nobody in here with parking tickets, we will look up someone who we might know from the SQL community who has a license plate that might match their Twitter handle. And he knows I'm doing this, by the way, because I've done this before. So we can go ahead and we can look up Brent's tickets real quick. He no longer lives in Chicago, and don't worry, he paid them all, so he's good. But we can go ahead and query this. This takes a little longer because we're looking for specific records. They're still indexed. It's still going to be pretty darn quick compared to what it takes, but it is a little more effort, right? So here we go. We got 4 parking tickets for Brent for expired meter and parking or standing or whatever, and he paid them all, so he's a good citizen. And he's on a cruise ship right now coming back from Hawaii, so hopefully he doesn't hear about this anyway, unless you tweet him. But that is the demo script that we're just going through this parking ticket data. I have this demo script available for download. I also have the data available for download if you'd like to play with it yourself. So with that in mind, let me go back to the deck here if it's going to let me switch slides real fast here. We have some resources. This is all available on a GitHub page I have. The link is at the bottom, and I'm going to switch to the next slide, which has the same thing. So if you go to bobpusateri.com/r/dippingyourtoes, it will take you to a GitHub page that has this slide deck, that parking tickets data if you want to play with it yourself, and the notebook we just worked through. Again, I have my contact information up here. If you have questions, feel free to reach out to me on Twitter or email. And we have, what do we got? We got 10 minutes. I can answer any questions anyone has right now if you like. Otherwise, thank you very much. Yes?
So is Parquet what you recommend as opposed to like U-SQL?
Is Parquet what I recommend as opposed to U-SQL? Well, U-SQL is a query language and Parquet is a file format. But if I was doing this work, I would generally take and not work in raw CSVs. I would transform it into Parquet first and then query off of that. You're going to see the performance benefits you noticed in the demo with that. So yes, I would do that. Yes? What did I have to do to be able to type that in?
What did you have to do when the parking ticket data itself, they were all on file?
Yeah.
How did you know to get the data out in that format?
How did I know to get the data out in that format? So that data was originally posted online as a Postgres database, actually. So I actually first used it for a SQL Server presentation, so I translated it into SQL Server database and saved it off that way. But then I wrote a PowerShell script that would basically query out the tickets by day and write them out to CSV files. And I mean, it can read any format you want. CSV is pretty darn common, so that's what I worked with and just said I'm generating 1 CSV file per day. You know, let that run for half an hour or whatever as it wrote out that many thousand files, and then you're able to point Spark at it in Databricks and say, hey, read these files, and that's all it did.
So if you have PDFs or video files or something like that, the queries would look like
The query would look a lot similar. You'd just be pointing at a directory of that. You'd be calling different functions saying, hey, read a PDF, right? Because the CSV function's pretty standardized. Everybody, you know, PDF might get you a little more work involved, but basically you'd be defining it as PDF data, using an adapter to do that, and then pointing it at that directory. Yes?
Related to that, how do you recommend organizing video or audio files or image files?
How do I recommend organizing video, audio, or image files? Generally, I do it by date, or if there's an ID in your system that you're already using, you know, tagging it to metadata, have it be that way. Yeah, you can.
You can have one folder with multiple audio files.
Is it okay to have a folder with multiple audio files? Absolutely, but I wouldn't have a folder with 50 million audio files in it either. So, you know, a couple thousand is usually what I found to be a sweet spot. Any other questions? Over here, sorry. Yes?
Is there best practices for organization of these data lakes? I mean, I just see that it looks like it's open for swamping like quickly, right?
Is there best practices for organization of these data lakes? Absolutely. You can read a whole bunch of opinions about that, but generally it's you know, use a standard zone, divide by the data source, and then usually something like a date. But yes, it is absolutely ripe for becoming unorganized quickly, which is kind of where wrangling and governance are necessary. So yes.
So in your parking ticket example, you assume that all the files are the same format. But let's say in 2015 they introduced a 4-digit year, or something changed about
So.
data. So you have to pay attention to this.
So the question is, how do you make sure the file format doesn't change? Well, in my case, I enforce that through my creation. This is where you'd be going from the raw zone to the curated zone. You'd probably be saying, okay, raw zone is how they actually delivered it to me, and maybe the format did change at some point in time. So now I'm adjusting my processing of it as well. But by the time it gets to the curated zone where we're actually working on it, they would be uniform and agreed upon at that point. So yes.
What is the argument of moving from existing HD Insight Data Lake to Azure?
What is the argument of moving from the existing HD Insight Data Lake to Azure Data Lake? I do not have an answer for that. I would say go ask a Microsoft person here. They could probably articulate that, but I cannot. So sorry. Yes. Can SQL Server stretch databases store in Data Lake? I do not know for sure. I don't believe so because I haven't seen it mentioned, but I'm not totally sure. I don't think so though. Anything else? Yes.
So since there's a cost to your queries to read from the data lake, is there a set of tools that would let you know this user in your organization cost you $100,000 over the course of the year? This person cost you
So because there's a cost according to this, are there tools that will let you know that is more an Azure feature? So yes, you could set up and say, hey, I want to know, what's the billing, break it down by account. That's an auditing type thing at that point. Yes.
So it's not just limited to just get like a line item that said Azure Data Lake store had 700,000 queries, you owe us $1 kajillion. Like you could break out.
I believe you can break that down. Yes.
Okay,
So
thank you very much.
no problem. Anything else? Nope. All right. Thank you all very much for coming. Hope you learned something and enjoyed.